So it wouldn't be chemistry if there wasn't a demonstration, right? And it's part, and parcel why I became a chemist. Is because you get to do things that normally would actually make a mess. Unfortunately, as an experimental chemist, you have to clean it up too, but I'm gonna have some help tonight. But it's things like this, right, where you can make colored solutions and actually have something bubbling that sort of inspires you. This is a little cliche, but a little, we just got done with Halloween. However, you can start to use this in more creative ways, and as you grow up, you realize that these mixtures in what you do can actually be utilized in ways that you normally wouldn't think about doing. So right now you would think that I'm doing another reaction and maybe it'll change colors, and possibly, in fact, do something unexpected like explode. But no, we're not going to get there. I wanted to do something that was relatively safe. And even though tonight is going to be a movie about cooking, I wasn't going to be able to cook on stage. However, now I've got a solution, and in fact, it's doing the same thing. And since it's an Italian movie, and it's a movie about food, I actually thought I'd make myself a Negroni. Okay, so this is what I was talking about, what happens when you learn chemistry and use it to do something that's creative and a little bit different. So the expanding carbon dioxide that's filling filling the container, once it fills the container, creates the pressure, it actually pushes the cocktail now into my glass. So I already warned them I was going to pull a Dean Martin. All right, so the movie's going to be about food, and you're actually going to do this, or you're going to see a lot of different ways in which food is utilized. And what I thought I'd do is actually talk about one of the chemistry reactions that's happening when you sear food or actually brown it. And it's all those good flavors. So all those smells, that brown caramelized flavor, that's a Maillard reaction. So the Maillard reaction is a reaction that was first discovered in 1912 by a French chemist named, or a French biochemist named Louis Camille Maillard. And what he was doing was actually trying to reproduce the synthesis of proteins by heating them up. And he was actually heating up amino acids. And what happened was that he heated up the amino acid and smelled it and realized that it sort of smelled like a steak. And it's right now it's a little bit apropos, right? Because what we're entering into that time of year where we're going to be doing a lot of eating. And it's that seared brown color that's just, perfect on the turkey, duck, or chicken, however you end up celebrating the holidays. Okay, so the Maillard reaction is actually done in 3 stages. The first thing that it does is take the protein and combine it with the sugar. And when it does that, it actually links the two. And so the sugar is actually going to help degrade the protein itself by setting up this conjugate between the two. So that's the first step, and you can actually start to see this in the browning of the carrots. Now, as this goes along, it sort of starts to rearrange itself and isomerizes as it sets itself up to do what it finally does when you start hitting those higher temperatures, and that is start to break apart. So what you start getting are these aromatics, these heterocycles, these things that you can start to smell that are smaller pieces, and that's what you're getting when you eat the food or smell that searing meat. And that's usually what results from the browning of bread, any baked goods that starts to brown, especially with a lot of sugars and protein, and then also steaks and things of that type. So what are some of the compounds and sort of the flavors that come along with those? So let's actually take that seared steak. What you get are pyrazines that give you that roasted, cooked flavor, the furanones that are a little bit sweet and caramelized, and then the furans, which is that burnt flavor. And all of these combine to actually create the taste and the smell that we all know and love. Brussels sprouts, so caramelized Brussels sprouts are a little bit acidic and they're a little bit acrid, and so they produce some different types of aromatics. So the pyridines and the pyrazoles and the oxazoles, these are all things that, again, are from green leafy foods, but they have that sort of nutty caramelized flavor when you actually go to taste them. And then lastly, so tonight, again, you're going to see a lot of pasta. We're talking about an Italian movie. And that's a little bit different. So these are the breads and the cereals, things that have kind of like that cracker-like taste when it's cooked and seared. So this is baked macaroni. You're going to get like a nutty pyrazole, some furanones, again, for that caramelized color in the acylpyridines. Which actually taste more like the cracker once it's cooked. And so tonight, as you're watching the movie and seeing all the different flavors that come out, realize that the chemistry that's going on is happening right there at that sear level, and it's chemistry that's ultimately giving the flavors that ultimately make you want to continue to eat and consume more. The quote I always use is that a chef is just a chemist using limited inventory. So with that, I'm going to let them start the movie and thank Beth and Kathy for the opportunity to share some food chemistry.